Good morning. Morning. Hey. All right, well, we now start chapter 24, and we really come to what I think is the pinnacle of organic chemistry in terms of reactivity, mechanism, synthesis, retrosynthetic analysis. And this is the carbonyl chemistry of various types of carbonyl condensation reactions, the aldol reaction, the Michael addition, the Claisen condensation, the Robinson annulation reaction, the intramolecular Claisen called the Dieckmann cyclization, the intramolecular aldol reaction. It's putting together the reactivity of carbonyls that we learned about as electrophiles and the reactivity on the alpha carbon as nucleophiles, and being able to assemble some very complex and important and beautiful molecules as a result of this. There's also a lot to think about. And so what I'd like to do is to start talking about the aldol reaction, which really lays the groundwork for all of these carbonyl reactions, and indeed even some of the sugar chemistry you'll be learning about later on in chapter, I think, 28 or 26, I guess. All right. So in the aldol reaction, in general, what happens is an enolate reacts with another carbonyl compound. So you have a carbonyl compound, and I'm going to write this very, very generically. A carbonyl compound with an alpha hydrogen, and honestly, we're talking about
into a sword or a plowshare, I guess, if you want. So you can start banging into whatever shape. You can imagine the impact that a material like that had on society. So that's chemistry, immensely practical.
All right, students, thanks for tuning in. Let's do a review of some basic chemistry for the APES test. So first we'll talk about photosynthesis. And this is what is done by all producers, including plants and algae. And the chemical reaction for that is that they take CO2 from the air and they combine it with water to form sugar, which is C6H12O6. And this sugar can then go on to form